Hello, this is the second part of the intermolecular forces where we discuss the remaining types of intermolecular forces. So the previous four, if you want to check out, please look at the previous video. Now in this we look at the ion induced forces. So this is similar to that of the dipole induced dipole forces, but in place of dipole we have ion here. That means these interactions are between an ion and a non-polar molecule. So non-polar molecule could be here. We can take iodine I2, and the ion that we consider here is the nitrate ion NO3 minus. So what will happen here is the ion that is already charged, when it is placed near to the non-polar molecule, this ion will induce the dipole in the case of non-polar molecule, because of which this can be split into positive and negatively charged ion. In such case, the forces of attraction that exist between the ion and the non-polar molecule, which is now turned into a dipole, is nothing but ion induced dipole forces. These are the most commonly seen intermolecular forces in the covalent molecule, where there is very less electronegativity difference. Electronegativity difference is very less or almost 0 or 0. Now London forces are also called dispersion forces, or they are also called van der Waals forces, which is named after the scientist van der Waals. So these van der Waals forces exist between the non-polar molecules, as we already discussed, because it exists in the covalent molecules. Covalent molecules, mostly they'll be non-polar, but we can have few polar covalent molecules also. Now in case of non-polar molecule, for example Cl and Cl, now there are two electrons between the two chlorine atoms. Now these two electrons are equally distributed between Cl and Cl. Then the molecule is neutral and it is non-polar. But these electrons are not located at a single position in a fixed way. So what they do is they randomly move in all directions possible. So as they are moving in random directions, we can see sometimes both the electrons being deposited at the one position and leaving the other atom with no electrons. This can happen for a few fraction of seconds. Such dipole created for a very less amount of time randomly is called instantaneous dipole. Now because of this instantaneous dipole, this chlorine becomes Cl minus, this chlorine becomes Cl plus. Now the neighboring chlorine, which is normally neutral, will now get induced because of this dipole created in the Cl and Cl. Now this also becomes Cl plus and Cl minus. Likewise, whole molecule becomes now induced dipole, or the positive negative charges are created in them, because of which we can see partial attractions between the one molecule and the other molecule. Such weak attractive forces that are present between the non-polar molecules are called London forces or dispersion forces or van der Waals forces. Now, the magnitude of these London forces will depend mainly on the factor called polarizability. Polarizability. This polarizability we mainly check for the anions. For example, if we have F minus anion and I minus anion, this anion is small with a negative charge, and this iodine anion is large with a negative charge. So due to the small size of the anion, it cannot be polarized, or its negative charge cannot be pulled or deformed that easily because of its small size. But for iodide ion, because of its large size, the negative charge cloud can be easily deformed. That is nothing but the polarizability of the anion. So the small sized anion's polarizability is less compared to the large sized anion polarizability. This is the main factor on which the London forces depend. And also these attractive forces are proportional to R power 6. Forces are inversely proportional to R power 6. London forces increases with the size, with the molecular weight, with the surface area, and also with the number of electrons. These all factors will increase the London forces, which we can say these are the favorable conditions for the London forces. Last type of intermolecular forces is the hydrogen bond. Now the hydrogen bond is mainly seen between hydrogen and the most electronegative elements of the periodic table, that is fluorine, oxygen and nitrogen, and in the least case you can find a weak hydrogen bond in sulfur. So mostly it will be found in fluorine, oxygen and nitrogen. So the attractive forces that we see between the hydrogen and the electronegative element is said to be hydrogen bonding. So if you look at water molecule, oxygen is the central atom, hydrogens are the bonded atoms. So here you have negative charge, positive and positive. Now water molecules, between one water molecule and the other water molecule, we can see the hydrogen bonding this way, which is represented by a dotted line. Such interaction between hydrogen electropositive element and oxygen electronegative element is called hydrogen bonding forces. Now the strength of the hydrogen bond depends upon the difference in electronegativity between hydrogen and the electronegative element with which it is showing the attractive forces. The energy varies between 10 kilojoules to 100 kilojoules of energy per mole of a substance. So these are the different types of intermolecular forces that we see in covalent molecules and various substances.